there. My name is Ryenn White. We're with the CompTIA student chapter at UTSA. I currently serve as the president.
I'm Ryenn White, and I currently serve as the vice president of the student chapter.
And we're going to be talking to you today a little bit about cybersecurity. But before we get into our presentation, we're going to have a few ACM announcements from Alex.
Sorry. Hey everybody. I'm Alex from ACM, and I guess I'll just do a couple quick announcements before we get started with our presentation today. So I guess just a couple of things here. Here's our social media handles. We usually use Discord the most to get out our announcements, or if you'd like general discussion with other members. But usually we'll post announcements first there. But we're also pretty active on our other handles, as you see on the screen here, such as Twitch, YouTube, Instagram, Twitter, Facebook, and sometimes LinkedIn, I guess. But yeah, these are social handles. And so here's a couple of announcements before we get started. So membership is free for the so to be a member of ACM, it's free, but all you really need to do is attend 7 meetings for the semester, and you just need to register on this link we're showing here on the slide, or the QR code. And so when you're a member, you're given a T-shirt, a yearly T-shirt, as well as some other benefits, as you see here in the slides. If you'd like to scan the QR code for being a member, I can leave that for a second, unless you are all good. All good? Okay, I'll go ahead and move on. So kind of to reiterate, just as long as you attend 7 ACM meetings for the semester, you'll become a member. And that doesn't include just these general meetings. We also have some other, sub-organizations, and those can count, like ACM-W and Icpc. Though I guess for Rowdy creators, if you're in a project, I believe one meeting only counts every other week. But yeah. Are we good? I think on the laptop. Oh yeah, sorry guys, technical difficulties. So just this past weekend, we had some people volunteer at the STEM fair. And we just want to say, for those of you who came out, we appreciate it. And it was fun. So far we've only got this picture, but it was glad to see some of you there. And in other news, Icpc also had their local contest this weekend. For it was and solved a couple problems. So just as a congratulations to these 3 teams here. Team 3, Team 4, and Team 6, with Team 3 having William, Jose, and Brandon, and Team 4 having Jeffrey, Ryan, and Brian, and finally Team 6 having Ivan, Hamza, and Benjamin. Thank you guys for participating, and I think we'll have more in the future, so look forward to it. So we've decided on a new meeting time for the next semester. We're gonna hold our general meetings from 12 to 1. So so that's what we mostly decided on based on a couple of your votes on the Discord server, or from the majority. But yeah, be on the lookout. And we also have an opportunities calendar, and usually that has a lot of events, for people. So maybe if you're interested in signing up for a couple hackathons, the opportunities calendar provides kind of a convenient way to find those opportunities and locate them all in one page. So in case you're interested, we'll just leave this for a couple seconds here, so those of you can get a QR code. All good? So here, just a couple of examples of what's coming up here. As you can see, a couple hackathons. But yeah, look forward to it. And here's a couple of upcoming events. So on the so this Friday on the 12th, a couple members from the CS faculty will be reviewing your resumes, and so we'll release sign-in forms pretty soon this week. So be on the lookout for that. But you essentially reserve a 15-minute slot, and when a couple of members from the CS faculty review your resume and critique it. We also have our weekly Icpc general meeting, which is on goes from 10 to 1 on Saturday, and it's a hybrid meeting, so it happens on both in person in the makerspace, but as well as on Discord. So be on the lookout for that. And so next week we have an Intro to Tech workshop on Docker, and that'll take place on 2 to 3 p.m. Next Monday. Again, a lot like most of these events, it'll also be hybrid, and we'll have a guest speaker there. So be on the lookout for that. And we also have another general meeting on the 17th, and that'll be from 12 to 1 as per the usual time, which is also hybrid. And yeah. And the last for upcoming events, we also have another ACM-W general meeting going on Thursday, I believe next Thursday from 3 to 4 p.m., also, which is also hybrid. And then finally, next Friday, we'll have the CS department and a couple members from industry review your resume. So a lot like the faculty one, you can reserve a spot and have them review your resume. And again, be on the lookout for that. And so finally, here's the sign-in link for today's meeting and the QR code. We also have a link there. But yeah, like I said, 7 meetings, and make sure you register, and you'll be a member. I'll just leave it there for a minute in case you guys need to get that. And also, if you missed it, don't worry. We'll also have it at the end in case you also need it there. Is everyone good? Okay. And I guess I'll give it off to Ryan and Ryenn here. Thank you.
Awesome. Thank you so much, Alex. So like we said, we're going to be speaking to you today a little bit about cybersecurity. We know that as computer scientists and programmers, you might have an interest in it, but I know in your degree plan, you might not get an extensive amount of information about the field or things that come with it. So some of the things we're going to be talking about today is just the industry as a whole, some of the jobs that you have the potential to get as a programmer in cybersecurity. We have some things about laws and liability of developers and security teams. And we're also going to do some pretty fun, in my opinion, live demos of some code exploits and malicious code demos. So stay till the end if you want to see that. That's the fun part. But just as an introduction, I know a lot of you are probably familiar with the cybersecurity industry, but it wasn't always the intense, horrible thing that we see in the news every single day. I know if we turn on the news every morning, there's definitely probably going to be a ransomware attack or something else happening to one of the largest enterprises in the world. That's just kind of the world that we live in today, but it wasn't always like that. Cybersecurity in the very beginning, in the 70s and the 80s, hackers actually began with programming backgrounds similar to yourselves, and they weren't hacking with malicious intent. They were actually just hacking because it was a hobby of theirs, and it was typically college students or academics or researchers that used their programming knowledge to begin hacking, but like I said, not malicious. They weren't trying to get financial gain or ruin anyone's lives from it. It was just, for fun. And then over the scope of many years, it's transformed into the intense industry that we have today, where we're having ransomware and pretty devastating attacks happening daily. The cybersecurity market today is projected to grow over triple the next few years, which is a very large amount. Right now we have attacks averaging at $3.86 million per attack, and that's globally. But unfortunately, the United States ranks #1 in most expensive cyber attacks, and we average about 8.6 million in losses per breach. So just a little bit about the threat landscape that we're facing right now. Most of the attacks that we see are financially motivated. So obviously we know about ransomware, but we also have phishing attacks. You have cross-site scripting where they want to reroute your banking transactions to their account. A lot of these are financially motivated just because it is very motivational to get money out of hacking you. 72% of our attacks are done by outsiders from organizations. That leaves 28% of our attacks being done by insiders, and insiders typically have a more extensive and deep knowledge and understanding of their organization's network, so they sometimes can be more equipped to pursue these attacks than outsiders, but outsiders typically have different intentions than insiders. 17% of attacks today involve malware that could range from ransomware to spyware to all kinds of things like that, viruses. And 22% include phishing and social engineering. Of course, we all know phishing. We get those little scam emails that are telling us we need to click this link right now, or something really horrible is going to happen and we need to send them money, all that kind of stuff. But social engineering, if you're a little bit less familiar with it, it's a variety of tactics used by adversaries to get you to do something that allows them to exploit a vulnerability. For example, a really common one is impersonation. So someone could call you and impersonate an IT employee from your organization and say, hey, I'm Mark from IT. I need your password to do whatever I need to do, and then you give me your password, and then, you know, the world catches on fire. Or for social engineering, you could also have, you know, you pretend to be the janitor and you go into the computer lab and you have access to all of these things. A lot of social engineering also involves tactics like emotional manipulation. So if you ever get those emails that are like, all of our dogs are dying from this really strange disease and we need you to donate at this link here. Or a lot of social engineering targets the elderly as well, because they're a little bit less aware of those kinds of attacks. But that's a little bit of the threat breakdown in the landscape that we're seeing today.
So as Ryan kind of mentioned earlier, you know, a lot of CompTIA students are interested into maybe some aspect of cybersecurity, but may not kind of get that in their degree. So I was kind of just gonna give you a taste of some of the cybersecurity jobs, or more into the cybersecurity realm types of jobs that have a lot of programming involved and require proficiency. So for example, for one of the first ones we have is the DevSecOps engineer. So DevSecOps is a methodology that is developers and security operations. So it includes very close partnerships between the security operations teams and the developers to make sure that code that developers are putting out are secure. So a lot of what this has to do is when developers are testing their code and putting it into like a beta environment or development environment, they'll run like fuzz tests, or they'll run some type of test to see, you know, okay, is this update gonna bust our application or something of the sort. So working closely with security teams there to just make sure like your code is secure. Security automation engineer, that's more something of the lines where you'll be using scripting or you know, programming scripts to automate business processes or IT processes. So a script could be for, I don't know, every day you want this script to run through and scan all the hosts on your network to check if there's any vulnerabilities on there, or any changes, or there can be tons of things you can do with scripts. So that's one of them. And then lastly, something that may be a little more interesting and more niche is offensive security developer. So I'm sure some of y'all have heard of red teaming, offensive cybersecurity, penetration testing. So offensive developers really work with the penetration testers and red teams to develop tools to, it can be tools from ranging from enumerating onto a system. It can be tools to help scan and get reconnaissance. It can be a large variety of things. Definitely a more niche area, but interesting for sure if you're interested into like offensive and attacking and, you know, that kind of stuff. So some security skills that will be helpful for CompTIA students, and I'm not sure how much they actually teach this in a degree plan, but for instance, input sanitization and validation. So, you know, when you're developing like an application and you have like a text box or I don't know, like a username box, or just something that takes input in, you don't want people to be putting special characters, or you don't want to give them the range to put whatever they want in that box, because that really gives them the ability to test, you know, and see, okay, are there any vulnerabilities? Are there any kinks in the application that are going to let me maybe query something or try to pull something out from behind the scenes. And I'll kind of show that later in a demonstration. So making sure that your input is sanitized and clean before you actually put it into the application. Error handling. So I'm sure this is harped on a lot in coding, that if your application is not handling errors properly, if something goes wrong and it doesn't do what the program is expected to do, it has to have some way of either resetting that back up or securely ending the program. Because there are instances where if you don't have proper error handling, it could maybe lead to an open terminal or some type of situation where the application doesn't know what to do. And it may allow the user to exploit that and run some of their own scripts or applications on it to bypass or get root access or whatever they're trying to do. Scripting and automation, a lot of the popular languages, sure you'll learn these too: JavaScript, Python, C#. Those are very common languages seen in the industry. Keeping it simple. So in cyber, we like to have a phrase that we want to keep things simpler, not more difficult. So if you're adding functionality to a application that it's like, why do we have this? Is it necessary? Well, that's just leaving more attack space for people to test around and see what they can really do with your site or application. And lastly, quality assurance techniques, peer reviews, have somebody review your code, have somebody check up on it, checks and balances, that kind of thing. And I'm gonna have Ryan go into data protection laws and liability.
Okay, cool. So something that we don't really get to talk about a lot in university, especially as programmers or people pursuing computer science degrees, is the legal aspects of the jobs that we're about to get into. And legality is really big in cybersecurity. We take a lot of, legal and policy classes and things like that, but it's just as important for developers and the roles that you're going to get into, because you'll be handling the sensitive data of customers as well. So we have equal responsibility in protecting that. And so something that I just want to touch on very briefly is the laws that we already have in place regarding how we're required to protect and respect the private data of our customers. So of course we have our cybersecurity laws that are already in place that I won't touch on too much because they're pretty technical, but we have our Federal Information Security Management Act, 2 of those, and some other ones that are just based on auditing and certain security baselines that companies, enterprises, governments are required to follow and abide by to make sure that they have like the baseline secure protocols. But we also have to abide by personal information laws. So as you can see, there's children's online privacy that we have to protect. Graham Leach, Bliley, and the Sarbanes-Oxley, these are accounting, financial, things like that have to do with auditing financial information, credit cards, all of things like that. Hipaa, obviously we have our health information privacy. This is something that is very important, as I know you've probably seen that hospitals and medical centers are having a lot of breaches at this time, especially with the pandemic. And so any breach of data within the medical field is also a breach of Hipaa. So that's something that we end up being liable for. And then also if you end up working for a global enterprise, you will have to follow GDPR, which is a policy that is in place in the European Union. They have quite stricter laws on the regulation of their data in transport and processing than the United States and other countries. Their privacy laws are much stricter. And so if you work for a global enterprise that passes data through Europe, or the data is originated in Europe and it gets transported elsewhere, those are protected under much stricter guidelines, and there's much more things that you have to follow when you're processing them. So that's a little bit about the laws and the protections that we have to follow, but this is important. I know it can seem a little bit like boring and a little bit of a drag, but it's important for our jobs because as developers and cybersecurity professionals, we come into the field knowing that we have a responsibility to protect the people's data, because we work for our companies, but we work for the consumers and the people who are using our programs that we're developing and using our applications and things like that. So we have a responsibility to them, especially if we're taking in some of their sensitive data, like their social security number or their credit card number and things like that. We have the responsibility not only making their lives easier because of the great application that we've made, but also to protect the data that they've trusted us with. And when their privacy is struck and we've had a breach, then we are held our company is held legally and financially responsible for these breaches. Sometimes you will end up going to court. There have been cybersecurity teams and developers that actually have to appear in court and testify on, what they've done in regard to the situation, their response, and everything like that. So we do have to be a little bit familiar with the laws that pertain to our field, because they might come up someday, and it's better to be prepared than to kind of go into them blindly. But now, for the time that everyone was actually waiting for, we're going to get into some of our live demos. So for this first one, who knows what a buffer overflow is? Nice. Josh, what's a buffer overflow? Josh says when memory space is exceeded. Yes, absolutely. So this first exploit that we're going to do is very simple, so don't get your hopes up, but we're going to dip our feet into the water a little bit. It's going to be a buffer overflow exploit. So I'm going to go ahead and pull up the program that we'll be using. It's a little bit difficult to talk while doing command line, so you'll have to give me a little bit of patience. Okay, so the program that we're going to be using is called Overrun. It is written in C. And I'm going to give you a brief overview of it. I won't go too in depth because I'm not a programmer and I don't know C. But this is what we're going to be using, and I'll tell you basically what it's doing. So when it prints out, basically all it's doing is going to ask for my name, and then it's going to say, hey there, which is pretty simple. But if you'll notice, we have these functions called malloc. And as you can probably assume, we're talking about allocation. And what this is doing is we're taking a name variable and a dangerous system command variable. Your programs aren't going to be written like this, but for the example. And these functions are allocating a certain amount of space to the input that we're requesting from the user, right? So let me go ahead and exit out of this, and we'll run it just normally, as if I don't know how I'm going to hack it. So it's telling me the address of the first variable is that long list of numbers, and the address of the second variable is that long list of numbers. And then it says, what's your name? My name's Ryan. Hey there. Yeah. But as we can tell, we've been given these two address numbers, and these are the amounts of bytes. In between these two addresses is the amount of bytes that is reserved for the input that I've put in, which is my name. So what we can do is I'm going to take these numbers, and I'm going to find out the amount of address space that is in between them by subtracting them. 32. So this means I have 32 bytes, 32 bits that are reserved for this input space. So if I run this again, I know that when I type right here, my input, what is your name? This is accepting 32 bits. So what happens if I put in a 32-bit long string? I hope that's 32 bits. And then I can execute whatever arbitrary command I want to, because I've exceeded the amount of address space that I've reserved for it. So, for example, I'm going to concatenate the Linux password file. What do we think? Is it going to work? We'll see. If you don't know this command, cat is concatenate. It basically just means it's going to print it out in the terminal. The password file, a little bit self-explanatory. Let's see if it works. Oh, guys, we got a password file. How cool. So if you're aware of Linux and you're familiar with it, you know that the password file doesn't actually show you any passwords. If you see, we have our root account right here, which is our highest admin privileges. There's an X for all of these. With the password file, the X is just a placeholder for the password, so it doesn't actually appear there. But what we can do is there's something called the shadow file, which has the passwords in hashed form. So I'm going to concatenate the shadow file, again, printing it into the terminal. And we can actually see here, up here I have my root account, which is the admin with the highest privileges, and we have this very long hash value right here, right? And this entire thing is going to end up being the password that I've given to the root account. No one hack me, please. I'm just kidding, it's a VM, it's fine. Then I have my demo users 1, 2, 3, and 4, and instead of these X's here, we have our password hashes. If you'll notice up here, just some fun facts about Linux if you're interested, these stars up here mean that you're not able to log into these accounts with a password. So as you can see, we have like our sys and our bin and our daemon. You can't log into those with passwords. They require other authentication practices. But I'm not going to show you how to crack these passwords because I think that would be a little immoral. But I can explain a little bit of how bad people do it. So if you look over here at this web page I have pulled up, oh, ignore the ads, we can see that it gives us an explanation on what each of these fields means in the shadow file. So for example, we have, if you'll look right here, color D, that coordinates with the username of the account. That is before the first colon. In between the first and the second colon, that is going to be our encrypted password. That's all I'm going to show you right now because the rest of it isn't really important to us. So in this second field, the encrypted password field, we see these $signs, right? So Callie over here, we have these $6, $6. What does that mean? I can't hash a $, right? I don't know what that means. So if we go down, we do a little bit of research on the internet because everything is available publicly these days. We can see that the format for this shadow file is we have $type, $salt, $hashed. So this hashed at the bottom, at the very end, that's the actual password. The salt is the salt that's used for the hash algorithm, and the type is going to be the type of hash algorithm used. So for anyone confused, hashing is a little bit different from encryption. Encryption we can reverse very easily. Hashing is supposed to be irreversible because it's a one-way algorithm. But we can tell these are hashed in $6, which is SHA-512. So if I really wanted to, I guess I could maybe figure out how to do that. I'm not going to show you how to do it, but one thing to keep in note is that anything that is hashed, you're not going to be able to reverse it. What we do with password attacks, me acting like I do them. What we do with password attacks, there's various apps that we use for them. Normally, we're using John the Ripper or Hashcat. And with these programs, we have lists that are preset that have a bunch of like the most common passwords that people use, like passwords in there, you know, a bunch of dictionary words, things like that. Actually, let me see if I can print one for you and just show you. Okay, yeah. We got rocku.txt. This is a common one. So these are some of the most common passwords that people use that are written in this huge file. I know this is a little painful. Let me stop this. Okay. And we use these files with the programs Hashcat and John the Ripper to crack commonly used passwords. So if someone is using the password, you're going to be able to crack it with John the Ripper. The passwords that I've put on this VM, you're not going to be able to crack it with John the Ripper because they're not dictionary words. Of course, that'd be a little embarrassing for me, wouldn't it? But anyways, this is kind of how bad people go about password cracking. But overall, mostly just an overview of how buffer overflows work. So obviously we're told in our classes that we need to make sure we're validating our input and everything like that. But I don't know if we're really shown the consequences of our actions when we don't. And I just got access to the password file and the shadow file of a Linux machine. And if I was really, really smart and good at hash algorithms, I might be able to do some pretty bad things. But I don't recommend doing this at home. We're going to pass it off to Ryenn for our next couple of demos. Let me unplug. Does anyone have any questions or comments so far? Yes, sir. So he asks, for the buffer overflow, are we just overflowing the memory? So whenever we ask for input in a program, that input is pointed at a certain space in address. And when we, or memory or storage, and when we allocate a certain amount of space for it, it's given however many bytes we're given it. But if we allocate space and we fail to validate the input, like for example, if I say, okay, please enter your 4-digit PIN for your bank information, but I don't limit your input to 4 digits, you have the rest of it. I'm not going to say invalid input because I forgot to do it. You're going to put in 4 digits and then you're going to say concatenate the password file, and then the world's going to catch on fire, right? So we have to allocate the address space or the memory space, but we also have to validate that if we are expecting only a certain number of bytes for the input, we also have to add that so that people aren't exploiting that sort of failure in our code. Does that make sense? Any other questions that we can answer for you? Okay, we're going to pass it off to Ryenn. Are you screen sharing? We got this.
Okay, I want to do some preferences. Yeah, sorry. Sorry about this. Okay. All right. Sorry about this, y'all. Just one moment. Stop. Lovely. Okay. Good. All right, cool. Thank you, Ryan, for that lovely demo of Buffer Overflow. Now I'm going to be going into showing you one logic bomb, which is going to be, it's like malicious code. So I'm not going to like show you how to code something malicious, but I'm going to kind of give you what you can do with a logic bomb and kind of what it is. And then I'm going to go into a short demo of Sql injection and just how you can mess with databases on websites. So first, what is a logic bomb? So essentially what a logic bomb is, it is a part of the malware family. And so a logic bomb is just an application that embeds itself into a legitimate application. It kind of the code is hidden. And once an event happens, which you can make this event anything, it can be from on a specific day. It can be when you open like a certain executable file. So many different things you can do. I'll kind of show you what I did for mine in a minute. And once that event happens, it's something, the trigger is blown and the bomb goes off. So in that case, the bomb can be a lot of different things. It can be from deleting files, like it can be from, shutting down your computer. It can be a lot of different things. So logic bombs are difficult to detect because what antiviruses work off nowadays is what we call signatures. And they are basically, so a lot of malware have common like things in the code that says, hey, this is a virus or this is a worm. And that's what we call signatures, things to look out for within these malicious viruses, malware. Logic bombs, they don't really have a signature per se, since they're hiding within an application's code, they're dormant. So nothing malicious is happening when a logic bomb is just sitting on a computer. So you can have it sitting on a computer for months. Nobody even knows it's there. And then boom, the event goes off and it gets triggered. So now why would somebody really want to do this? Well, most common scenarios we see is angry employees. So, someone gets fired and they're not happy how they got fired and they still have 2 weeks before their job is over. Well, that employee has inside access to the network. They have still privileges to their account. They could easily go into, within their own computer or within the network and plant a piece of code, since they have easier access to the infrastructure, plant a piece of code inside a legitimate application. And so let's say when they're fired, they're terminated, that is the event and the trigger is going to go off. So that's just kind of a little backstory on like a logic bomb. And so now I'm going to do a live demo of it. So I didn't, I didn't like plan like a malicious, like my computer's not going to explode or delete all of my files on it or, anything like that. But just kind of showing you, a little something of it. So imagine, you're getting on your computer, you're waking up or whatever you're doing, you're logging on. So just logging on to my computer. Cool. Oh, this is really nice. Why is it so zoomed in? Anyway, so this executable just popped up out of nowhere from me opening my computer. Okay, I'm going to play with this. So let's see. Press any key to continue. You have been hacked. Oh, shoot. That's really scary. So a bunch of weird faces. And a bunch of stuff is happening. I didn't click anything. What is happening? Oh, no. This is not good at all. I'm just going to X out of all this stuff. Pressing the key to enter, and then some weird matrix things are happening. So yeah, this is kind of a silly demo, but the demo is showing you that this is the kind of the concept of a logic bomb. So what happened was, I'm going to show you the code to it. Let's see. So it's just a very simple bat script. So basically, it's just echoing some stuff to the screen, blah blah blah. It's calling to some files, some GIFs I had, and then it's calling to another bat file. So it's a very simple program. And if you're wondering, okay, well, how do I do this? So a lot of, there's something called a task scheduler in Windows. Some of y'all may be aware of it or not. And so what you can do with task scheduler, let's see, can you see this well? It's maybe too zoomed in. This is really zoomed in, but 1 second. Let me see if I can fix this. It's okay. So what you can do with task scheduler is you can actually start processes in here. So let's see if I can actually show you this. Oh, here we go. So you can create task in here. And so you can name it, you can put a trigger on it. So a lot of executables, like what people will do is they will get onto a system, enumerate it somehow. And once they're on that system, it will drop a payload. And so the payload could be this logic bomb, and the script will actually create a task automatically through the script. And so in here, what I did was, all you can do is you can put a trigger. So what will actually make that task go off? And you can put an action is what's going to happen when that trigger is blown. And so let me see if I can actually find mine. It's really zoomed in, so it's going to be hard. It's okay. I don't need to pull it up. It's just a really simple thing to do. But in this case, does anybody have an idea what the trigger was for the code to actually go off? Anybody? Any idea? It's okay if you don't. Logging in, exactly, yeah. So I logged into my computer, and based on the login, that was the trigger for the event to go off, and then it executed the bat file that I had. So that's just a little sample of a logic bomb. Before I go on, did anybody have any questions or anything on that? Okay, cool. So I have one more demo here. It's pretty short, but I'm going to give you a little background first. So this next one is what we call SQL injection. So if y'all don't know what SQL is a really popular database query language. So MySQL is like one of the most popular used databases within companies. And so what I'm showing you here is, so this is just an example of what behind the scenes would look like. This is a very simple database using Microsoft Access. So I have this Nintendo database right here. It just has some usernames, IDs to map them, and then it just has some passwords for them. So this is just like a very simple username password database. And so what I did was here, this is what we call a query. So SQL kind of, the way you ask for stuff from the database is kind of how you would talk to somebody. So I see, so it's saying select, and asterisk means any. So select anything from the Nintendo table I have here where the username equals Toad. So this is the result of that query. And you can see it pulled me my username and my password and everything related to Toad, the username Toad, into this database. So that's just a little background of what it looks like in the very simple SQL database. And now I'm going to show you how you can exploit that. Okay, so I have this website here. It's a pretty simple looking website. It's just your typical banking website. Ignore the demo site tag in the top right corner. So, normally you would use a username and password that correlates to something in the database, because when you're logging in, what it does is it checks behind the scenes and it checks the database and says, okay, yeah, we found this username and here's the password or the hash of the password, and it gives it to the machine, bam, matches up, you're logged in. So I don't have a username and password. This is not my banking system. I don't even know what this is. I'm just going to try something. So I'm just going to do a very simple statement. And I don't know a password, so I'm just going to use password. Wow, but look at that. I was able to get admin access to this banking website through a very simple SQL query. And that's what we'd like to call Sql Injection. So I'm going to show you what actually happened here. So we break this down. So how SQL queries work. The beginning, you see how there's like one quotation? Well, there's another quotation that's not shown within the query that it's not going to show. So I'm basically saying blank a string, and same thing with encoding, just a simple or statement. So I'm saying or the condition 1 equals 1. So what I'm telling it is, I'm saying, hey, find me where the string is empty or where 1 equals 1. So as you'll know, 1 equals 1 is always going to be true. So that is a true statement. And so since this satisfies the statement and there's no input validation to stop me from putting asterisks, from me putting plus signs, equal signs, whatever I want to put, I can input whatever I want here. And this is really bad. If you don't have this in here, people can play with your system and they can see, hey, let me see if they have any databases I can mess with. Can I do SQL injection? I don't know. Can I do code injection? There's a lot of things you can do if you don't properly sanitize your input. So that's pretty much the demo I have. It's pretty simple. Did anybody have any questions on that or anything? So normally, so to counteract this, so normally in almost any scenario, you're not gonna be able to input any special characters like that, because special characters are what allows you to, scripts and SQL queries require special characters. So a way to combat that would be not allowing them into the actual input. And so, or even if you did try to put it in, it would be like, it would automatically be like, no, you can't do this. Like, does that kind of answer your question? So yeah, but you don't try this on any websites because I promise you it's not going to work. No website is going to have something that simple vulnerable. It's really a rookie mistake. But I just kind of want to show you what a SQL injection is in a very basic form. So let me see. Is there any more questions? Okay. So that's what we had.
That concludes our presentation today. Thank you guys so much for being with us and spending your afternoon with us. We had so much fun, and I hope you had fun too. So thanks for spending your time with us. We really appreciate you. Huge shout out to ACM, Janelle, and Alex for having us. We've really loved our partnership so far and hope we can do some more events like this. If anyone has any questions for us or just want to talk about cybersecurity, we'll be here for a little bit. But other than that, thank you guys so much. Have a great Monday.
Take care, y'all.